Hello everyone. Today we will review three IB challenging questions on Pythagorean theorem. Question 1, 2, and 3. Before jumping to this question, I suggest you watch my last two videos first, which gives you important key points you need to follow along today's question. Video 1 and video 2. Okay, without further ado, let's dive into questions. First example, find the value of n such that the given set is a Pythagorean triple. It means you're given three expressions depending on n, and they can form the Pythagorean triple. If this is the case, it means if you have a right angle triangle, these three expressions can be sides of the triangle. As a result, let's begin by substituting given A, B, and C into Pythagorean theorem formula. So this one is A, B, and C. Usually they are arranged based on A, B, and C, most of the triples. So let's raise them to 2 based on the formula. A squared would be 2n plus 1 to the 2. B squared would be 2n squared plus 2n raised to the 2 equal c squared would be hypotenuse squared, which is 2n squared plus 2n plus 1 raised to the 2. Now carefully expand each square terms, simplify, and bring it back to the equation to find n. Let us start with the first one. So following the identity or writing them twice and expanded, you will get 4n squared plus 4n plus 1. Yes? For the second one, we will get 4n to the 4 plus 8n cubed plus 4n squared. And for right side, I'm going to use the identity, the square of trinomial identity. If you remember, we had a plus b plus c to the 2. This is identity, and it would be a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. Let's apply to right side. We will get 4n to the 4 or n4 plus 8n cubed plus 8n squared plus 4n plus 1. So keep the right side unchanged because there is no like terms. We are going to simplify the left side. I'm going to rearrange the terms based on a standard form from highest order. So I'm starting with this. So I'll get 4n4 plus 8n cubed plus this one, which is 4n squared, and then continue with those terms. Let me change the color, would be 4n squared plus 4n plus 1, and then equal to the right side, unchanged. So let's simplify the left side. I have two like terms here. These one just carry down, 4n4 plus 8n cubed. I'll get 8n squared plus 4n plus 1 equal, and from right side I have 4n, which is this, 4n4, 8n cubed, 8n squared plus 4n plus 1. As you see, both sides, they are equal. So what does it mean? It means for any value of n, the equation is valid, and the set is a Pythagorean triple. So therefore, the result would be for any n greater than equals 0, the set is a Pythagorean triple. But before concluding this result, let's just check some special values. So to do so, the special values is starting with n equals 0. Let's see if this is valid for the equation or not. If n equals 0, and if you substitute n here to both legs and hypotenuse, you will get the set 1, 0, 1. We don't have such a size, okay? So as a result, for n equals 0 is not valid. How about 1? If n equals 1 and you sub it to sides expressions, you will get 3, 4, and 5, which is correct. This is Pythagorean theorem. It satisfies to Pythagorean theorem formula, and they can be sides of a right angle triangle. So as a result, we have to change our expression, the final conclusion. This one should be changed. It's not for any n greater than equals 0. It would be for n not 0, greater than 0, and n should be integer number, not real number. Then after, the triples would be Pythagorean triple. Example number 2. Find the height of triangle ABC. The triangle is given. Triangle ABC is given, and we are going to find the height, which is labeled as x. So the strategy is that look at the whole figures and find as much as you can a right angle triangle. I can see one right angle triangle left side, one in right side, and one in total shape. Okay, so we are going to maneuver to each of them individually and see what we can find. Okay, having that, let us start with the left side, which is the in yellow one. In yellow one, I can apply this one, let's say A, B, and C. Applying Pythagorean theorem formula, I can get 3 square plus B is x square, and C is C square. I'm going to use its own name. The C square, C is AB. I'm going to use its own name, would be AB square. So I get 9 plus x squared equal AB squared. Can I solve this equation? No, because I have 2 variables. I'm going to keep this one as a relation number 1. Now I'm going to work on other right angle triangle, which is in blue one. In blue one, again, I can apply Pythagorean theorem formula. So therefore, in blue one, which is in triangle ADC, I can say 6 square plus B was x. Yes, here was x. Therefore, 6 square, x square, and this one is C. Plus x square is equal C square. For C square, again, I'm going to use its own name, which is AC. Yes? So it would be AC square. I get 36 plus x squared equal AC square. Again, I cannot solve this equation. I'm going to keep it as a relation number 2. In third steps, we are going to look at whole shape, which is triangle ABC. In triangle ABC, okay, in triangle ABC, this is our A, this is B, and this part is C. Yes? So let us apply in triangle A, B, C. We can write down A square which is AB squared plus B squared is AC equal C squared, hypotenuse is 3 units and 6 units. Together would be 9, yes? So therefore it would be 9 squared. So now I'm going to replace AB using relation number 1. Instead of AB, I can write down 9 plus x squared, yes? For AC, I'm going to use relation number 2, which is equal to 36 plus x squared. Equal, right side, I get 81. Now you have an equation that you can easily calculate x. So just adding up constant term, I'll get 45, and x's I have 2x squared equal 81. Moving this term to the right side, we get 2x squared equal 36. 36. Dividing both sides by 2, we get 18. And then take a root from both sides. We will end up that x is nothing but 3 root 2. It's better to keep it exact value, and the unit is centimeters. So you find, therefore, the height of ABC, triangle ABC, the height which was labeled x is nothing but 3 root 2 centimeter. Last example. Question asked, find x. As you see from the shape, x is this length, and x is part of this small right angle triangle. To find x, I need this part, and I don't know the value, and I need this length. However, if you look at the overall shape, you see there is a semicircle, and OB is a radius. If this one is 5, it means here is 5, and here is 5 as well. But still, we don't know C to this point. So therefore, we need to change our strategy and look at to the bigger triangle, which is ABC. Over ABC, I know this is 5, this is 5, this is 8. Easily, I can calculate CB. So therefore, let's substitute the value in the Pythagorean theory. Okay, so over the triangle ABC, we can write down, let's say this one is A, this one is B, and from here to here is C. So A squared would be 8 to the 2. B squared, we don't know. I'm going to use its own name, which is BC squared equals C squared is 5 plus another 5. Because this one is 5, this length is 5 as well. Yes? So therefore we get 64 plus BC squared equal 10 to the 2. 64 BC squared 100. BC squared, if I move this term other side, would be 100, take away 64. So BC squared would be 36. Taking a square root from both sides, therefore the length BC is nothing but 6 centimeter or meter or 6 units. Okay? Keep this one rule back. So therefore, it means from here to here is 6 centimeter. As a result, half of it from here to here would be 3 centimeter, and from here to here would be 3 centimeter. Yes? So now we can apply. Let me erase the rest. Now we do know this. So now I'm going to work in this right angle triangle, the small one. Let's label this one capital M, this point. So The color is not that much clear. Let me change it. I think this color is better. I'm going to label this one M. So in the triangle OCM, we can write down, this is 5, yes? So we can write down 3 to the 2 because it's half of the 6, yes? Plus x to the 2 is equal hypotenuse, which is 5 to the 2. So therefore we get 9 plus x squared equal 25. X squared is moving this term right side and subtract. So x squared would be 16. Taking root from both sides, we end up that x is nothing but 4 units. That's all for today, guys. Thank you for watching. I'm a mathematics teacher, love to share my many years of teaching experience with students everywhere. If you find this video helpful, please like and subscribe. Your likes and subscriptions help me achieve my goal and keep creating great content for you and other students. Please share this video with your friends and classmates and leave your thought and comment down below. I would love to hear from you. Also, if you need more practices, please visit my website, mitramath.com. Under tab Free Practices, you can find more. See you in the next video. Until then, take care and bye-bye.